So, as I was saying, half of you are computing majors, and the other half of you are other majors, mostly math majors, but some physics, some accounting, information science, and some others. So you may have different needs in taking the class. I mean, the basic need is it's required. You know, very few people take the class because they want to. It's normally because it's required. So you want to do well in the class. And so the way that I've kind of handled the class is I try to make it accessible to everybody, whatever your needs are. Maybe you just want to learn a little and you still want to get a good grade. You know, it's not your passion, it's not your focus. It may be important to you, and that's the reason it's required. You know, there's a reason for things being required. They're not always the best requirements, but in many cases they're at least roughly important and relevant to you and your career. So that's regardless of your major. That's the reason you're in here, because somebody, some faculty, thought that, believe that this is of importance to you. Anyway, so what I'd like to do this quarter, which is a little bit differently than the other quarters that I've taught this in, is to kind of break the material up into two areas. So one is the minimum required knowledge and skills, which are sufficient to get an A. And then extra material, which is really relevant and useful and necessary if you plan on making a career that involves computer programming. You know, so all the computing majors, for instance, and even non-computing majors, you'll be surprised at the opportunities that you'll find later on. Well, I think, how do I know? But based on history, that a lot of people go into, they get involved in some kind of computer programming in their careers, regardless of their major. I mean, that's a minority, but it still happens. All right, so the assignments are listed here. And these are correlated with the lab sessions. So I call them assignments because you really can't complete these, most of these, during the lab session itself. You need to work on it outside of lab as well. So these are, but the lab session is there for us to help you and give you time to meet together. You can even help each other. To basically work on these assignments. So these are the assignments, and these are the deadlines. This is the assignment that's due on April 8th. So for half of you will go into lab today. When you go into lab, you want to first, with the help of Juan, the TA, you want to first learn how to log into the computer system, and which means learn what your username and password is, which will be different than your university username and password. And then open a browser and go here and start reading. And in particular, go to this assignment and start reading through this. This is what you want to start doing today. Even if you don't have lab today, you can start this today anyway. You don't need to go to lab to do this. What you need is a browser. You can do all the work in this class, all of it, 100% of the work in this class, using a browser. That's the first time I've taught this class that way, by the way. Last time I taught it, which was in fall, that I prototyped this, and about half the class used this approach, and it worked very nicely. So I decided to make this a required approach. Basically, you create this account on this system called Cloudnine. And what you do is a virtual machine instance is allocated for you, some remote server. and then you'll start working in that virtual machine instance. And you'll do your work there, and you'll submit your work to us through that mechanism. So I'll show you more about that later. And lots of details, what happens if you're on a lab machine, then there's some notes on what to do. If you're working remotely, but you're on a lab machine, but this, I think, is going to be non-typical. This is if you have a Mac, if you're running Linux, if you're in Windows. So these are based on the computer system that you have access to, whether you're in the lab, or if you're at home, or you're on campus using your laptop. And you're welcome to use your devices in lecture here. I'm happy to see everybody do research and reading and even working during the lecture period. So feel free to pop those things out. And all right, so this is just the instructions. There it goes. And then in every assignment, I have a section on how to submit your work. So you just read that and carry out those instructions. All right, so this is the part where you do things, right? So these are the assignments. This is the work you have to do. And this command line assignment is, you can finish this, and you can go on and do any number of assignments without waiting. And I recommend that you study ahead to get ahead, because what frequently happens is that you'll be working and you'll be stuck on something, and you'll be stuck for a while, and it takes some time to get past a roadblock. And so if you work ahead a bit, you'll get that buffer. So in case you need to slow up a bit, you're forced to slow up, you won't fall behind. So I advise to just go as fast as you can in the beginning and get ahead, work ahead. So you can do any number of these assignments as soon as you like. You can finish all of them in 2 weeks. Although that's a lot of work in 2 weeks. I don't expect you to do that, but theoretically you could. And also in this list I have exams. So I have 3 exams, 2 midterms, I guess you call them, and then a final exam. And each of these links will show example problems that may appear on the exam, problems similar to these. This is what the exam looks like. It's just these are the problems, the type of problems that are on the exam. So there's no mystery about what you need to do, what you need to what your grade is based on, and how that's assessed. There's no mystery about that. The mystery is, how do you figure out the skill that we're assessing? So this is mostly about computer programming. Right? Computer programming is a form of problem solving that involves inventing an algorithm or algorithms to solve some kind of computing problem. So you hear there's a statement of a problem, and now create a program that does something. Create a program that plays tic-tac-toe. That's a big problem. That's our final problem. That's in the last assignment. That wouldn't be a problem on the exam. It would be a simpler problem. It would be a computing problem that would be a component of a larger program, like a program that plays tic-tac-toe with the user. So the final problem in the course is to write that program that plays tic-tac-toe with the user. And when you write that program, it's a big program. I mean, it's not that big, it's pretty small. But it's relatively big relative to the little baby problems that you're given and that you're tested on. So this bigger program is comprised of lots of little solutions, little problems with their computing solutions. These are assembled together to solve a larger computing problem, like implementing a video game. And that's the way software works in general anyway. So, in this class, you're going to be learning about software development, right? Not just listening to me talk about it or reading about how it's done. It's about actually doing it. So this is a hands-on class. To do well in this class, you're going to practice much more than you will read and study. It's all about practicing. It's like, to make a pretty straightforward comparison, a video game, right? I remember the old days, in old video games, you used to get a manual. And I think I remember, was it Diablo 2? It was the first video game I ever played. I was 50 years old. It came with a manual that was 100 pages long, roughly 100 pages long. You know how I played the game? I'm a professor, right? I'm an old guy and everything. Never played a video game until Diablo 2. How did I play the game? I read the manual. 100 pages, can you believe it? It's just like, that's my training. I'm an academic. I do that. And then I played the game. I still had trouble. I had to ask students to help me figure out, how do you play this? How do you kill Bloodraven? I don't know. Does anyone know this game? Yeah. How do you kill Bloodraven? And Bloodraven's trivial, right? When I first started, it was like so hard. Anyway, it's just like that. And these days, how many people spend time reading manuals for video games? I mean, they don't even deliver manuals with video games anymore. They used to. But now you might have a tutorial. And it used to be, well, that you have a menu and you pick the tutorial from the menu and you go through this boring tutorial and you rush through it. You can't wait to play the game. But now they don't do that anymore. Now they integrate the tutorial in with the game itself. So you start with simple gameplay, and the game, as you're playing the game is teaching the user how the interface works. What are the rules of the game? So they make it so easy. And I'm trying to make it easy for you in this class, but I got to tell you, it's a hard class. I mean, that's what people say, right? But I try to make it as easy as I can. And in a sense, I'm designing it to be like that video game, like a contemporary video game where it's got a built-in tutorial. You don't even notice that you're in the tutorial. The game is teaching you how to play it itself without you even sort of realizing it. Well, anyway, that's the reason for problems. Some students, they've got this habit of studying and memorizing and taking the exam and reproducing from memory what they had studied. You can't do that here. There's a few problems if you memorize everything I present, and you may see a couple of exact problems come up on the exams, and you say, oh yeah, I memorized that one, and you can write it down there. But most of the problems are unique. You take an exam, you're going to see most of the problems are going to be completely unique. So memorizing won't do any good. You have to memorize certain things, like what does the equal sign do, and the syntax of the programming language that we're studying. Although mainly you need to practice. You have got to take problems, challenge yourself, or take the problems that I give you as suggested problems and practice. And you practice that, just like playing a video game. Just jump right in there, start practicing. And when you're stuck in it's video games, obviously I think a lot about video games now. So when you're stuck in a game, what do? You go on YouTube and you look at a playthrough, right? Is that how you do it? So I'm going to give you lots of playthroughs here too. So I want to make it easy. Try to make it easy, just like a video game. All right. So these are the assignments, and these are the lectures. And this is the first time I've done it this way. I decided to do it this way. Kind of disconnected from the book, although the book is in the bookstore and it's listed as recommended. You can buy it if you like. If you're taking 202, the instructor will probably require that book. So if you bought it already, it's not a waste if you plan on taking 202. If you're not going to take 202 and you got the book, it's good. If you get something out of the book, that's great. Now, more and more, I think people are learning without books, right? That's how I do it. I can't. I mean, I still read books, but when it comes to programming, everything is just out there. And so what I did this time for this quarter, it's my first time to do this, is I selected a tutorial, an online resource that you can look at. It gives a very good overview of the C++ programming language. And so that's our reference. It's going to be this. Let me show that to you. These are my notes. I had to make notes. This is what I want to cover in lecture, all this stuff. And I want to get most of the notes done, well before the end of the course. So each of these links here link to a section in this online tutorial. So I'm just going to go through the sections of this online tutorial one after another and demonstrate and talk about what the tutorial covers. It's called a tutorial, but I don't know if it's really a tutorial. Here it is, C++.com. And so here's the first section, first chapter. And it's talking about compilers. So I want to talk about what a compiler is. Let's see what it says here. So computers are hardware with software stored in them. And the hardware is just a mechanical thing. The software is a mechanical thing as well. Right? And so this software, which are the instructions, the hardware of a computer is very general. And you program it with this software to give it some specific functionality. And so, if you want a word processor, then you install a program that gives you word processing capabilities. So what is this program? The program is, if you look inside of, these programs are files. Right? A file is a sequence of information. It's actually a sequence of numbers. All files in the computer are just strings of numbers. And you can look at the numbers as numbers are just numbers. But when those numbers, so you can look at a number and say, well, that's 10 in base 10, right? But in base 16, it's A. It's the same number. I got A fingers in the air right now. I got A fingers on my two hands. I'm using base 16, the base 16 number system, number representation system. It's the same number as decimal 10. It's just the system of representation is different. And then you have octal numbers, base 8. But ultimately, in the computer hardware, whatever sequence of numbers that are in that file, those numbers are ultimately represented in hardware as zeros and ones. So you can look at the contents of a file as a sequence of hexadecimal values or decimal values, just numbers. It's a sequence of numbers. The hardware is going to represent that using a sequence of zeros and ones. It does it electrically. There's some sort of physical, electrical, magnetic representation of zeros and ones. So a program, when you run a program, a program comes from a file. What happens is the the numbers that are in a file are loaded into RAM, also called main memory. The file is normally stored in, what do they call it? Persistent storage. You turn the computer system off, the numbers that comprise the file are still there in the system. You turn the computer back on, the file is still there. It's in persistent storage. But then to run the program, you load the values that are in the file into main memory. Main memory is not persistent. It's volatile. They call it volatile memory. You powered down the computer system, you'll lose the representation of the program that's in RAM, in main memory. And so when this file is loaded into main memory, it's represented in main memory as zeros and ones. So your job as a programmer is to write programs, which means to produce these files of zeros and ones, which are loaded into RAM and are run on the computer system and provide the user with some kind of service. So how do you produce these files of zeros and ones that make that produce a video game or a word processor or a browser or whatever? That's what a compiler does. So you write the program in a human readable language like C++ or Java or C# or whatever. There's lots of computer languages, many. C++ is an important language. It's used a lot. It's a difficult language. If you can master C++, you've mastered maybe the hardest language out there. And there's a lot of important software written in C++. It's being maintained now. Operating systems and so on. Games, lots of things written in C++. And so you'll write a program using human readable language like C++, and then use a compiler, which is another program. A compiler is a program to read your C++ file or files and generate the numbers that can be loaded by the operating system into RAM and run as a program. That's what a compiler does. A compiler translates the human readable source code, we'll call it that. Source code, it's the source, it's the code, computer codes that are the source of the executable file. That's the program that you launch. You double click the file, right? Or however you start the program. Whatever command that you issue to the operating system, say operating system, I want to run this executable. This file is not a data file. It's a file that contains computer instructions. I want you to start running these computer instructions for me right now. And so you can tell the operating system to do that in different ways. One way is to double click an icon, in your file browser. And there's other ways. So we're going to use a C++ compiler. One here. There we go. This is important. Console programs. So in the old days, when I was your age, we didn't have graphical user interfaces like we have now. Like now we have this. We have a window here. See this? This is a window. And this window is being managed by a program called the Chrome browser. And so this program that's running, that's managing this window, the inside of the window, the tabs, and so on, this is called this is a program with an operating system window. But there's another kind of program which is called a console program. And those are the kind of programs that only existed in the past. When you launch the program and it runs, the program as it runs has no concept of a window in which it's running inside of. See, the browser, as this program runs, it knows that it has a menu. It tells the operating system, I want a menu. I want the menu items to be Chrome, File, Edit, View, History, Bookmarks, People, Window, Help. This is the Chrome web browser program telling OS 10 to render a menu with these items in it. So there's communication between the running program and the operating system. The operating system provides some resources. One resource it provides here is this window environment. When we write, we're not going to write programs that run in window environments directly. We're going to write programs that are old-fashioned console programs. And the environment that they run in is simply what's called a command line interface, a text interface. So all of the programs that we'll run are console programs. Although we'll see towards the end of the quarter, maybe we'll look at some graphical programs as well. Okay, so that's an option if we want to go in that direction. So you need to have a compiler. You need to have a program that's going to read your source code and generate executables from it. So we're going to use Cloudnine, and Cloudnine has its own compiler built into it. So you're all set there. So if you want to do the minimum amount of work in the class, you just learn Cloudnine, use that compiler, you're done. But if you want to learn more, you might want to figure out how to set up a development environment on a local system. Cloudnine is a remote system. It's a remote computer, and you're writing your code, compiling and running in a remote environment. But if you want to try to compile and run programs in your local environment, then you need to have a compiler. And here's, in these notes here, some names of popular compilers. Code Blocks. It runs on, there's versions of Code Blocks for Windows, Linux, and Mac OS. Visual Studio Express. By the way, that's different from Visual Studio Professional, right? Express is the free version, the student version. It does everything the professional version does. So don't buy a professional version. It's not worth your money, guaranteed. They're essentially equivalent. There's a very, very little differences. And those differences will not come against in all the times. If you're here for another 6 years, you won't even see the difference come up once. Dev C++, that runs on Windows. I never knew about that one, but there's another one for you. And but they don't list that. But on Mac, it's Clang, C-Lang or Clang. That's the compiler that's built into the what's it called? The development environment on Mac. What's that called? Does anyone know? I forget stuff. I'm getting older. What's the name of the development environment? How do you make mobile apps? How do you make an app and publish to the App Store? What tool do you use for that? Are you talking about Xcode? Yeah, Xcode. There you go. Xcode. So Clang is the compiler that's a part of Xcode. And if I demonstrate that, you'll see I can access that compiler from the command line. I don't have to start the Xcode graphical user interface. So in this class, we're going to do stuff from the command line. Keep it simple. The Xcode graphical user interface is so complicated. So is Visual Studio. They're very complicated things and highly, important. Go into the real world and write, work on projects, real world projects. You're going to be using those tools. Those have to be mastered eventually. That's that's part of your career. You do software development. You got to know Xcode and Visual Studio. Those two in particular. Those are the two big ones. Eclipse and the Eclipse-like IDEs, like NetBeans and whatnot. Those are also important too. Eclipse is used for doing Android programming and other things. That's one. A version of Eclipse has been modified and changed. So that's a compiler. Let's go ahead and practice with that. Let's see if I have anything. Oh yeah, this. So we're going to be learning a language, and no, not French, not Greek. We're going to be learning C++. That's the language. Like I said, there's lots of languages out there, but now the language has versions. So it's all computer languages are evolving. Actually, all programs are evolving. Even games. When you open up Steam and all of a sudden you see, oh, Terraria is updating. Oh, I got to play Terraria again because it just came out with a new update. So the programs, if they're being used, they have to be maintained. So they're always growing, they're always changing. And that's true about computer languages as well. And C++ in particular. Now the version of C++ that the tutorial covers is C++ 11, that's what it's called. And in the compiler that we use, in Cloudnine that we will use, in other compilers, this may not be the default. There may be a different version, an earlier version, or even a later version. This is not the most recent version. The most recent version is, I don't know what it is, C++ 14, I think. I don't know. But there's some new features in C++ 11 that I never taught before and I never used. I was just, because the older versions of the language are sufficient, and most code is written in older versions anyway. But I got advanced students doing work using mechanisms, using features of the recent versions of C++. I couldn't read their code. And so I think, oh, I better keep up here. So I'm gonna take a look at some of the newer features. Although if you look at standard code, like from a textbook or older code, you won't see these features. And this is the command line to specify that specific, to execute the compiler. This is the name of the program, that's the name of the compiler, or it's a name that launches the compiler. And these are the command line arguments. There's two command line arguments. This command line argument is an option that specifies the version of the C++ language that we want to adhere to, and that's C++ 11. You can see that option, it starts with a dash, and then you've got this name of the option, std, standard, then an equal sign, and then the value that it's equal to. So it's a name-value pair. That's when you drill into that. But the whole thing itself is the first command line argument. So we call that a command line argument. And this is the second command line argument. This is the name of the file, the source code. This is the source code file name. And you're telling the compiler to compile that, read this source code, and generate an executable from that, the instructions in that file. Let's take a look at that. Let's see if we can do that. So let's see, where do I got that? Let's try to get to it this way. Cloudnine. Now, Cloudnine is free for our use, but you can also pay for it too. You don't have to buy anything to use this. So we're going to use the free version of this, this online resource. And Cloudnine gives you a software development environment. And so what you do is you may have we're going to use one project in this class. All the work that you do is going to be done in a single workspace. But you can have any number of workspaces. Yeah, I'm teaching another course called 405, Server Programming. So I created a workspace for that. And then I have a little project. I just created this last night called Wiki to write a program that implements a wiki, because I'm researching that to see. Maybe I'll use that in one of my classes in the future. And but I'm going to create a workspace just for this class. Now this is something I'm going to show you. You have to do this. If you go to lab today, you should do this in lab today. Right? If you go home, do this at home. So let's create a new workspace. Create a new workspace. CSE 201. I'd like to call it just 201, but it won't accept a name that starts with a number. So I'm going to say CSE 201. Please give this your name so that when we go and look for your workspace, we know the one that we need to look at. Okay, so use this name. And we can make it private or public. Well, you can't make it private unless you pay for the service. But we're using the free version of the service, so we'll leave this as a public workspace. That means other people can go and look at your files. They can't modify your files, but they can see them and they can copy them. All right. Now, what's going to get created? It'll be a virtual machine instance. Yeah.
Oh, so before we have access to this, we all have to create a certain login.
Yeah, you need to register. I have mine already. You can see it up there. It's a username and password. You have to use your email. You have to register yourself as a user with this site.
And do we have to link it to you somehow?
Yeah.
Or? Okay.
Yeah, you need to share it with Juan and myself. The instructions are in the lab, in the assignment. I'll show you that feature. Once I create the workspace, I'll show that to you so you know how to do that. Okay. So now, the software development, we refer to, software development is done inside of an environment. And you need to configure your environment to do that particular type of software development. If you're building a game, you need certain resources and tools that are different than if you're building a website, right, or a mobile app. Corresponding to that, we have different sort of starting states for your workspace to be created with. So this is to say develop a static website. This is for a dynamic website using Node.js. This is to, I don't know what that is. This is to create a dynamic website that uses PHP, Apache, MySQL. This is to write programs that are written in the Python language, command line programs. And this is another web development environment. Ruby, that's usually used for web development. C++. So if we select that, that'll create this sort of skeleton and these sample files to get you started. It'll create something called a makefile. But I think this is more confusing. We should use blank here, because if we use this, we're going to get a makefile. That means, oh, now we got to learn what a makefile does. I don't want to cover makefiles. It's extra. There's so much for you to learn. Right? So rather than using the C++ template, we're going to use the blank template. So this is stripped down, nothing in there. And we're just going to learn sort of the minimum amount here. Although it's good to learn how to manage makefiles, and ultimately you're going to need to do that. Well, I don't know about you, but some of you. So let's start with a blank workspace. And here it is. It's setting it up, creating the container. See that? I think they use something called a Docker. Docker containers. Anybody know Docker? It's a system administration topic. It's a very interesting system that's used for setting up and deploying these applications in virtual machines. Everything is moving toward the cloud and virtualization. So basically, we're going to be doing our work. We're just using the browser. You could use your iPad or your phone to do the work in this class. Because we're just using the browser to access a virtual machine. I mean, you've got a physical computer that's running virtual computers inside of it, and we're going to be operating inside of a virtual computer. And these virtual computers are configured with different sort of resources, different configurations, and that's what they're referred to as this container. All right, so there it is. You can see we have like a file system here. We don't want to mess around with that .c9 for Cloudnine. You're probably not going to want to go in there, okay? And then there's this README file. Here's the README. You can read this YouTube video here. It's nice, but I don't need that, right? So I'm just going to delete that. And I wouldn't play with this. I would leave that one alone. So here we have 201. And so each of these assignments that you have, this is the compiler's assignment. Let me see here. What do we have to do? Oh, sorry, this is the lecture. This is the lecture, not the assignment. For each of these assignments, you'll have a folder by that assignment name, except for the command line. This one, you don't need to have a folder. Yeah, this one you don't need to create a folder for this one. But for the other assignments, basics, algorithms, you need to have a folder. I'll show you how to do that. So we'll just create a folder. Where is that? New file. Where's the new folder? It doesn't show it, does it? How do you create a folder? Maybe down here. New folder. I had to right click in there. Yeah, that's weird, isn't it? So I can create a new folder here and call it basics. But that's not how I want you to create new folders, because one of the learning objectives of this course and this assignment in particular is to learn how to use the command line. So for preparation, you create this Cloudnine workspace. That's what we're doing now, right? I'm in OS 10, basically just using the browser. And then you need to go through this tutorial, this online tutorial right here. I don't remember, but I have an account. I should have logged in first. But you'll need to create a free account here as well. And we're going to use this site for this one exercise. It's called Codecademy. And it goes through this tutorial, and it teaches you about the command line. What do I mean by the command line? Here is in this window down here, maybe that's hard to see, huh? Maybe it's all right. In this window down here gives us the command line interface. ls, that's a command. You need to know this. So it's a list, the contents of the folder that I'm inside of. Basics. See, so we're in this folder here. Although it says workspace there, this is kind of a confusing thing. But we're in this folder. And when I do ls, I'm saying, show me what's in this workspace. Let's create another folder. and that will be algorithms. There it is. Now we have two folders. Now if I run ls again, oh, algorithms and base, do you see that? It's showing the two folders. So this is like the graphical interface. It shows us our file system organization, using this tree visual thing. And but down here, we're accessing the same information, but it's presented to us differently. And this is called the command line interface. Let's create another folder, arrays. Okay, let's create another folder called arrays. That's the fourth assignment in the class. But this time, instead of creating it using the graphical interface, I'm going to create it using the command line interface. That's mkdir, make directory, arrays, make directory arrays. So the command is mkdir, that appears first, and then it takes a single argument, the name of the directory to make. And I hit enter. Watch what happens. You see the graphical interface shows a new folder. So these are two different ways of manipulating the file system, the underlying file system, to give you two different views, two different ways of doing things and operating in that file system. I do ls down here, you'll see now I have three folders. So learning this command line is the main objective of the first exercise, the first assignment. Sometimes I don't even bother with this up here. I just like, all right, let me just I'll just maximize that. And now I'm in now all I see is this command line interface. So that was clear, ls. So I might go, I'll change directory into basics. The folders are also called directories. Those are synonymous. So I'm going to change directory to basics. And look at the prompt. The prompt now shows that I'm in a folder named basics under the workspace. You see this tilde character? That's called tilde, by the way. It's on the keyboard. That's an abbreviation, a symbol that represents the path to your home directory. So whenever you're interacting with the file system, you do it as a user authenticated to the operating system. And each user in an operating system, doesn't matter which operating system it is, Windows, this is Linux. We're using Linux here, okay? This remote virtual machine instance is an instance of Linux. So the user, each operating system manages one or more user accounts. And each user has a home folder in the file system. The file system is that part of the computer, like your hard drive, right, or the flash memory, or anything that's attached that has a file system on it, like a CD or flash stick, whatever they're called. They have file systems, and so the user has a home directory in this main file system here. If I go pwd, that's print working directory. It's a very old command, that's why it's pwd, print working directory. You have to know this, pwd. It shows the path to my current location in the file system. That's another thing. When you're using a command line interface, it's this concept of current directory. Where are you currently located in the file system? We're in a folder called Basics, which is inside a folder called Workspace, which is inside a folder called Ubuntu, which is inside a folder called Home, which is at the very top. It's in the root folder. And the root folder has no name. It just starts with a slash, that's it. I can look at the root folder, I can go ls/. It says show me the contents of the root folder. This is the root folder. And I could say, well, I see in the root folder, there's a folder called home. What are the contents of the home folder? Oh, just Ubuntu, that's all. It's only one folder inside the home folder. And then what's in Ubuntu? Oh, there's live and workspace. Well, what's inside live? You know, I didn't even see that from the graphical interface. You see, we're seeing something different now than what's in the graphical interface. The graphical interface is not telling me that I've got a live and a workspace here. The graphical interface is showing that I have something called CS201. That's not even visible from the command line. This is a sort of a modified version of what's really in the file system. The command line interfaces gives you a more direct and accurate view of the file system. And this works in Mac, and for those people who own Macs, you know, like, well, I'm like software developer, so I got to know this stuff. There's places in their file system that are not visible to you using the Finder. You go to the command line interface and you can get there, you know, especially under the applications folder, and then there's a library folder. So the command line interface gives you a lot of powers that you don't get with the tools that are oriented towards normal users. So developers need special tools, give them greater access to the computer system. All right, there's so much to talk about. There's Apache. This is the web server that's on Linux. So these are look at, you can drill down to forever here. I mean, it just goes on and on and on, right? No, there's nothing in there. So it's the command line interface. I can do clear. Just clear that out. Let's create our first program and run it. Let's do it in basics. No, I won't do it. I'll do it at this level. I'll do it in the root folder because this, no, I'll do it in basics. Inside basics, you've got, you know, an assignment folder. Create an assignment folder called basics. And in there, the source code file should be named like this, ex1.cpp. That's the name of the file that solves the first exercise, exercise 1. And I'm going to just get started on this and show you how that's done. So inside basics, let's create a new file. They're called ex1.cpp. I go over here and I do ls, there it is. Look at that. And let's, I'll work in here for now. Let me see what I got here. All right, I'll just do this from memory here. So the program, let's see, is this what I want to do? Let me think for a second. So that's compilers. And then, so we finished this topic, and I'm running out of space here. Structure of a program. Here we go. There we go. Excellent. This is the next chapter in the tutorial. Structure of a program. So here's an example of a simple program. I'm going to copy that. And these are my notes. These are my lecture notes. You can read the tutorial. You don't have to read my notes. These are just notes about what I wanted to present in the lecture, but you can read them if you like. So here's an example program. So this is source code. This is the C++ language. These are a human readable form of the program. The purpose of this program is to say hello. When you run it, it says hello in the console. In the command line interface, it says hello. So this little icon up here, it means I haven't saved this yet, so I need to save the file. Let's see, now that changes to an X. And so there's the file. The file's in ex1.cpp. And I'm going to compile that. We can run the compiler by typing in C++, and then the name of the file. See that? That's good. Silence. That means it ran. But look, it produced a file, a.out. ls, see, a.out. That's the executable. That's the default name of the executable that's produced by the compiler on Mac, OS X, and Linux, and not on Windows. The Windows executables normally end with exe. We can run this program by typing /a.out. So it just says hello, that's it. Let's change the program. Let's make it say bye. There it is. So change the source code here. Now if we run it again, it'll still say hello because we didn't compile. We didn't translate the source code into an executable yet. So let's do that. By the way, I'm using the up arrow, down arrow keys to access the command history. That's very useful. I'm going to run this compilation command again. There it is. Now, when I run it, it says bye. We just modified the program, and now it has a different behavior. And so this is the program. What we're going to start off with is we have this section here. This is a comment. So everything that's in between this /* and //, this closes the comment, this opens the comment. Everything that's in here is ignored by the compiler. It's just for documentation purposes. This is called a multi-line comment. This is another comment, but this is a single line comment. It's just the comment starts with //. We could put single line comments, well, it's not single line comment, but we can have a comment here following at the end of the line. That's acceptable. The comment is not necessary. It's just for our use to help us understand to make notes inside the source code that are useful to remembering what we did. So I take those comments out, I still get compilation. It's good. Now the program is actually one line. It just says bye. In fact, let's do this. Let's modify the program. It's going to say hi and then bye. Hi and then bye. So we're expanding the program. Now the program, you can think of it as being these two statements. The first statement is print hi. The second statement is print bye. And I'm not getting into the syntax right now, but that's what these are two statements. And notice the statements end with a semicolon. So that ends a statement. Semicolon ends a statement. It's like a period in a sentence. And then, so we have two statements. But they're inside of this thing called a function. So the function name is main. A function is a block of statements. And you run a function when you say, I invoke a function, I call a function, I run a function, I execute a function. All those names mean the same thing. I pass control to a function. All those expressions mean the same thing. When you pass control to a function, you're telling the system that you want to execute the block of statements that are inside the function. Okay? But all C++ programs must have a main function, because that's the entry point. When you tell the operating system to run your program, operating system looks for the entry point. It can't just start randomly anywhere, because it won't run correctly. It has to start with the first instruction it needs to start at. And it doesn't know where that is. It's not the first spot in the file, by the way. It's somewhere else. So when you're in source code, you need to tell the compiler where the entry point is for your program. You do that by naming your function main. And by the way, main returns an int, which is short for integer. The function returns a value called an int, which is an integer, like a 0 or -3 or 4. Those are integers. 1,000, that's an integer. And then you've got an opening brace and a closing brace. And that, just like that comment, it demarcates the block of code that comprises the function. So we have two statements inside the function. There they are. That's our program. So in the beginning, we're just going to put code inside of main. All the work will be done inside of main. But then at a certain point, we're going to write our own functions. Well, pretty soon. And then we'll create new functions, like func. Let's call this function called func. I'm func. So we say hi, and then we call func. That's how you call the function. Say we print hi, we call func, which prints I'm func, and then we print by. There it is. Well, that's just the beginning there. Okay, so that's the structure of the program. Now there's some other things to notice here. This information. Let me simplify that. I'm going to take this out for now. Keep it simple. This is an include directive. So it's called a pre-compilation directive, a compiler directive. It's something that's done first before the actual computer code is then digested. There's sort of these stages of processing that the compiler goes through. This is done in the early stage, this include. It says, find a file named IOStream and copy its contents and paste it right in here. Include it. And this IOStream, this IOStream is actually part of the installed compiler. It's a part of the C++ language. The language definition requires that this file exist and provide certain sort of behaviors. And look at the name of the file. It's called IOStream. It's called a header file. This is a header file. IOStream. I is for input, O is for output. So it's an input-output stream. So we want to include, we need access to input-output stream functionality. So input-output, so input means you're reading data into the program. And output means you're sending data out. So it's your program has an interface. It's not everything. It has to talk to the outside. So you've got an input stream, data coming in. You've got an output stream, data going out. You can have any number of streams. But there's a default input stream and a default output stream. The default input stream is the keyboard, and the default output stream is the console. This cout here, this identifier, this name cout, is a name for the standard output stream. And this is an operation here. It says send in right into the standard output stream the string HI period new line character. That's what this statement does. It says it identifies the standard output stream, which we can do because we included this header. So now the compiler knows what that name is. If we took this header out, let's make that a comment, okay? Let's watch the compiler complain. Error, cout, you see that? Cout was not declared in this scope, and it's showing it right there. It's got this little caret symbol on there like an arrow to point to it. So it says, the compiler is now saying, I don't know what cout is. You didn't tell me what cout is. Well, that's because it's this included file that told the compiler or tells the compiler the meaning of cout. We're almost done. We're running out of energy, right? Not yet? Okay, good. Let's keep going. So, what about this? That's the last piece that we didn't look at yet. And this is a using statement. If we take this out, it's not going to know what cout is. Let's take a look at that. So another error. Cout was not declared, but wait a minute, I included IO stream. Now it's telling me, as if I had commented out IO stream, it's saying cout is not declared. And that's because there are so many names in a program. Programs can get gigantic. Right? How many lines of computer code do you think comprises Windows, the Windows operating system? Think about it. This is one line of computer code. How many lines total make up Windows? I mean, that's not Windows and all the software, not including Microsoft Word and Excel, just Windows. It's more than 10 million lines, I think. That's what I've heard. 10 million lines of code. That's enormous. Not obviously, one person cannot understand or manage 10 million lines of code. You need a large company. Or you need software that writes software. That's something people are working on. So to manage this complexity, and it's all about, a lot of it has to do with complexity when you get into programming. There's algorithms, managing algorithms, and how to specify mechanical processes to accomplish tasks, you know, like recognizing someone's identity by looking at an image of somebody, you know, taken in the airport, and they identify you from a database. That's called image recognition. So you've got, how did I get off on that teaching? Let me think. So you've got complexity. So you've got a lot of names. So you have to break them up into separate spaces. I'll give an example. My name is David, okay? And maybe there's another David in here. I don't know. There's another David in the building. There's a David. There we go. And there's probably there's too many. If I just said David and I meant any David in the building, we would have 30 Davids or 20 or whatever it is. So when I say David, I have to give a context. I say the David in this room. That's you and me. And now we've narrowed the scope. It's all about scope. So we want to give the name a narrow scope so it's precise, so we can identify what it is we're trying to name. If we just say David and we throw it out into the whole universe, we're going to get, 500,000 Davids. So like that, we use one mechanism that's used in this language is called a namespace. In many languages use the concept of namespace. It's a common sort of concept that cuts across software development. But in C++, it's part of the language. So cout is in what's called a standard namespace, STD. So I'm going to tell the compiler that this cout name is inside the standard namespace, the namespace std. So to do that, I prefix the name cout with the name of the namespace followed by 2 colons. I've got 2 couts there. Now you'll see that we can compile. There it is. But it's a little inconvenient. Some people think it's inconvenient to prefix all of the names from the standard namespace with std. And so to make it easier, we just say, let's import everything that's in the std namespace right there. All names that are in the std namespace, just merge them in with the current namespace, which is unnamed, by the way. So now this just is an ease. A lot of programmers will never ever do this. They'll just on principle they say, we're not going to do that. It's too sloppy. We want to write tight code here. We want to be really narrowly scoped. And so you might be on a team of programmers that say, we don't do this. We have to use std. That's one of our coding principles. But then you of course follow that, being part of the team. But for our purpose, it doesn't matter for us. We could do it either way. All right, that's a structure. So we covered, I got done 2 of these, didn't I? Now there's variables and types we'll do next time, and we'll just carry on from there. You have a question?
So, from what I said, I gathered that the lab sessions are there to help us, but they're not required to.
That's right. Lab sessions are there to help you. You're not required to go to lab. You don't have to. You're only required to take the exams in here. You're not required to come to lecture either. I'm going to post this video.